Good morning, fifth graders. It is time for lesson 3.1. You are going to make sure that you've already done the investigation 2 quiz prior to starting this lesson. In investigation 3, we're going to be talking about tiling and reptiles with starting with quadrilaterals. So in investigation 3, we're talking about scaling, perimeter, and area. And you've already seen a little bit of this with the scale factor and how the scale factor affects the perimeter and the area. You should see that the scale factor will be the same for the perimeter. So if you have a scale factor of 2, your area will be twice as large. The area, the perimeter will be twice as large. The area is the scale factor squared. So if you had the scale factor of 2, the area would change by 4 because 2 squared is 4. And we talked about that a little bit last week when you were learning how, because there are 2 dimensions in area, the length and the width, then that's why you would do the scale factor squared, because it is both dimensions are being doubled. So in investigation 3, it says, in shapes and designs, you learned that some polygons fit together to cover or tile a flat surface. So I don't think we did shapes and designs, but it's about 2D geometry. And you can see here that this would be an example of a tiling where you fit things together. Hexagons can tile, squares can tile, anything can tile as long as around this point of intersection, the angles all equal 360 degrees. So this works because each square has a 90-degree angle, and 90, 90, 90, 90 makes 360. The honeycomb works in the same way because each angle is 120. So 120 times 3 would be 360. Many bathroom kitchen floors are covered with pattern of square tiles. These patterns of polygons fit together are called tessellations. So for this activity today, you're going to be asked to make some tilings and some tessellations. If you don't have any pattern blocks or templates at home where you could draw these nicely, I did link in Schoology, and down here I'll show you a pattern block, an online pattern block. So you could make your tilings by pulling over the shapes on the website. If you are trying to do the triangles, which we're not going to do today, but you can rotate them using that button there. Looking closely at the pattern of the squares on the previous page, you can see that the large square consists of 9 small squares. The large square is similar to each of the 9 small squares. The large square has sides formed by the sides of 3 small squares, so the scale factor from small square to large square is 3. You can put 4 small squares together to make a 4-tile square. This 4-tile square is similar to both the large 9-tile and the small single-tile square. The scale factor from the single tile to the 4-tile square is 2. So because you're putting 2 across, right, a 2 by 2. The scale factor from the 4-tile to the small is 1/2. We talked about that again last week too, that you would, from small to big, what are you doing to the sides? And from big to small, what are you doing to the sides? And dividing by 2 is the same as multiplying by 1/2. No matter how closely you look at the hexagon pattern, however, you cannot find a large hexagon made up of similar, smaller hexagons. So you can see this is made of hexagons, but no matter how many more hexagons you put in there, you're not going to make another hexagon. And that's the difference between a tessellation or a plane tiling and a reptile. Okay, a shape is a reptile if you can put together congruent, which means same size, same shape, copies of the shape to make a larger, similar shape. The congruent copies may be rotated in order to fit together. A square is a reptile, but a regular hexagon is not. So thinking of the word repeat reptile would be if you can make it into the same a similar shape. So, which quadrilaterals are reptiles, or which ones can be made into reptiles? So, can you use rectangles to make a larger similar rectangle? Can you use parallelograms? Can you use trapezoids? Okay. For those that are, how might you subdivide them into smaller, similar figures? So you're thinking about how would you take that bigger rectangle and divide it into smaller rectangles so that it could be similar. So that's what we're going to be working on today. In this problem, you will discover which rectangles and non-rectangular quadrilaterals are reptiles. So it says sketch or use your shape set to make several copies of these shapes. And so this is where you might need that online pattern block. And then I'd like you to just sketch it out in your book. It doesn't need to be exact. You need to try these three shapes: a non-square rectangle, a non-rectangular parallelogram, and a trapezoid. So what is a non-square rectangle? It's what we would traditionally call a rectangle, right? Looks like there is not a non-square rectangle here on this, but maybe you could make one using two, right? Two oranges. And it looks like you might be able to change the color here. So I could change it. And so that would help me know I'm making, now can I make a larger rectangle that will fit this smaller one, right? Can I make it with a scale factor of 2 or 3? A non-rectangular parallelogram, so that would be this parallelogram, right? And a trapezoid. Okay, so these are the three you'll need: the rectangle, the parallelogram, and the trapezoid. Which of these shapes is a reptile? Make a sketch to show how the copies fit together. Look at your sketches from question A. What is the scale factor from the original to the larger? Explain. How does the perimeter of the larger relate to the perimeter of the original? How does the area relate to the original? So you should be able to figure out B2 and B3 based on what was your scale factor. C says extend the reptile pattern you drew for question A. Do this by sketching additional copies of the original figure to make an even larger figure that are similar to the original. So if you did a scale factor of 2 for the first one, now you should try a scale factor of 3 or 4. Find the scale factor from each original to each new figure. Explain. What do the scale factors tell you about the side lengths, the perimeters, the angles, and the area? And then you have ACE problems 1 through 3, 29, 31, and 33. And I'll go over the answers to the classwork in tomorrow's video. I will post the answers to the ACE problems in Schoology so you can check those on your own. All right, have a great day.